Hello, welcome back to my Connect 4 in Java tutorial series, and today I'm going to be giving you some examples of while loops and flags. So in the last tutorial, I went over the basic construct of how to make a while loop and gave a little example of how to use a flag. But I thought I could do a better job and put it in context in this video. So today, we're going to be looking at the check when condition D method, and that is the purpose of the method is to check for lines of 4 in a row in the diagonal directions. You'll notice it has the exact same parameters as the check when HV method, so that's checking for horizontal and vertical wins. The parameters are the same and the return type is the same. The return type is a boolean. The way it differs, however, is check when condition D uses while loops. So, I will say, tried recording this video earlier, and it turns out I had a few bugs in my program. So I was rambling on, and then I ran the code, and actually it didn't work correctly. So hopefully that's not going to happen again. Oh my god! Yeah, I don't actually know what I'm talking about. I'm joking. Well, kind of joking. Okay. So just a quick recap. These things at the top are known as parameters. And the first thing that we're going to do in this method is we're going to save a couple of the parameters. So whenever we use the parameters, we can use these variables like normal. You know, I can use move x and I can use move y, fine. But I want to save them to a different variable because I'm going to be changing the value. Move x and move y refer to the original position that the user's counter was placed in. So, you know, the bottom space, the bottom row, and the middle column, 3, 0. That's where the user place their counter. Move x will be 3, move y will be 0. And we want to keep that. We want to retain that information. So we're going to create a copy of it, and we're just going to call them x and y for simplicity. These can only be changed and edited within this method, and that's quite useful because it means that nothing else can mess up my my method when I'm looking for win conditions. We have a tally, the pieces in the line, so it's just going to count how many counters we have in a row. If it equals 4, then as you can see down here, player wins. We have a flag. So the flag is to indicate when a loop should terminate. At the moment it's set to true, and when it's set to false, the loop will terminate. The loop is here. So every time edge not found equals true, the loop will execute. Every time edge not found equals false, the loop is going to terminate. So that's all the setup. Now what are we actually doing here? What we're going to do is we're going to scan the board. In this first instance, we're just going to count to the edge of the board. And the reason for doing that is because if you think of a position in a 2x2 grid, there's 4 diagonal directions. However, if we count to the edge of the board, that narrows it down to 2. I'll demonstrate that for you now. So, if you imagine this counter has just been placed, this counter has 4 diagonal directions that we need to check. There's the sort of like southwest direction, southeast, that way, north, west, and northeast. So there's 4 diagonal directions. However, if we count to the edges, so if we count to this top and this bottom edge, then we only need to count in 2 directions. So say we get to here, all of this becomes one direction, as opposed to from here it's up and down, it's 2 different directions. Equally, if we count all the way down to here, all of these become one direction. And the reason for doing that is it just makes the counting process a lot simpler. Say you're counting in 2 different directions, and there's two counters here, and there's another counter here, you count in this direction, so you're going to get 3 in a row. Then you count in the opposite direction, you're going to get 2 in a row. But in reality, there's a total of 4 in a row. So the way to get around that is to count to the edge. There will be times, such as this counter here, when it won't reach this top edge. And the default, if that doesn't happen, is x equals 0. So if it reaches this column here. So what are we gaining by finding the edge? Like I said, we're narrowing it down to 2 directions. But what we're also doing is we're establishing the x or y coordinate at which we reach the edge. So when we reach the top row, so when y equals 5, we're going to need to establish the x coordinate. When we reach the bottom row, when y equals 0, again, we're going to need to establish the x coordinate. And if on occasion we reach x equals 0, we need to establish at what point what the coordinate y is. So this first loop is going to try and count to the bottom edge. So either we're going to reach the bottom row or we're going to reach the first x column. Once that's achieved, whichever value reaches 0 first, it's going to terminate the loop, and the value that doesn't equal 0, whatever the value it is going to be retained. From there, we're then going to use these starting coordinates to count diagonally up the board. So if you notice at the bottom, it's going to increment x and y by 1, and it's going to count up diagonally towards the top right-hand corner of the board. And it's very similar to the HV method, the horizontal vertical method. So every time the specified position within the game board equals the player's counter, it adds 1 to pieces in a line. If pieces in a line equals 4, then it prints out that the player has won the game, and it's going to return false. So that means it's going to trigger that's a use of flags. So what that means is that when it returns false, the return false refers to the return type of the method, and as a result, the method is going to terminate once it reaches this return false statement. Since 4 in a row has been achieved, therefore we don't need to execute any more code. If, however, it ever reaches a point where x and y don't equal the player's counter, pieces in line is reset to 0, and that is because the moment either an empty slot or the opponent's counter is reached, you have to restart your tally. You need a 4 in a row, consistent 4 in a row. It can't be 4 in the same diagonal line. It can't be the same horizontal line. It has to be 4 in directly connected. In order to achieve that, we need to reset pieces in line every time we find a counter that doesn't match the player's counter that we are currently scanning for. And then, like I said, it's going to increment x and y by 1. I'm going to bring up the board and I'll demonstrate to you what that actually means. Okay, so if we take this piece as an example, we've counted down, it's going to decrease x by 1, it's going to decrease y by 1, it's going to do it again. Y is going to equal 0, therefore the top while loop is going to terminate, the one up here. So it's going to count down, it's going to count down. Once it gets to here, y equals 0, therefore this condition is met, the while loop terminates, and we have a coordinate for y, which is 0, and we have a coordinate for x, which in this case is going to be 1. From here, it's then going to count upwards. So it's going to go from here. This isn't player 1's counter, therefore piece in line is going to be 0. Piece in line is not going to equal 4. And it's going to increase x and y by 1, so it's then going to check this counter on the next iteration. It checks it, it's going to add 1 to pieces in the line. Pieces line, however, does not equal 4. However, it has been incremented, so this statement is true, even though 4 in a row hasn't been achieved. Therefore, piece in line is not going to be set to 0, it's going to remain as 1. It's then going to increase x and y, and it's going to check this position. Again, it's going to add 1 to pieces in a line. So pieces in a line is now on 2. It's going to add 1 to x and y, and it's going to check this spot on the next loop round. It checks it. It finds, however, that it's 0. That means piece in a line is reset to 0. And it's going to do that again. It's going to reset it to 0 and again. And finally, once it reaches here, this criteria at the top, well, for starters, both statements are, I want to say, invalid. Yeah, so once it gets to here, it's then going to scan the position beyond. So x will be set to 7 and y will be set to 6. So this statement will fail and this statement will fail. And as a result, this loop is going to terminate, which is correct. There is no 4 in a row in this line, and the method hasn't found a 4 in a row either. So that's great. Okay, moving on. We're now going to go to the top row of the board. So we're going to reset the x and y because we need to find the edge again. So x and y are going to be reset to the values that they were at the start of the method. We're going to have to reset edge not found as well, since it was previously set to false. And we're going to reset pieces in a line just in case. Again, it's the exact same logic, except this time it's not counting towards the southwest, it's counting towards northwest. So while it's going to go backwards on the x-axis, it's actually going to go up on the y-axis. There will be times when it won't reach the top column of the top row of the board, and therefore we have this or x equals 0 statement in there. So in the instances when that isn't achieved, then it will count back to x equals 0, and therefore we can still say that we found an edge. When that happens, we take the coordinates that we found, pop them into this method, run the exact same code again, except we're going to be counting up in the x direction and counting down in the y direction, because typically we'll be on the top row. Therefore, we can't go any higher for y. The only direction we can go is down. You'll notice if 4 in a row is not achieved again, so this code is only executed assuming that 4 in a row isn't achieved on the first go round. If it isn't achieved again, then we just simply return true, and that means we've checked both diagonal directions and we haven't found a 4 in a row. So just to reiterate, if we take this piece as an example, it's going to count down in the x and up in the y. So it's going to check this piece, see if it's an edge. Then going to check this piece, see if it's an edge. It's going to check this piece, it's going to find this piece, and it's going to retain the y and the x coordinates. In this case, it's going to be 0 for x and 5 for y. When we then go into the second loop, it's going to add 1 to x, and it's going to drop 1 to y. So it's going to go here, it's going to go here, it's going to go all the way down to this piece at the bottom. And in this instance, it's not going to find a 4 in a row because there isn't one. Okay, so flags. Like I said, if a condition is found, if a win condition is found in either one of these methods, the flag will be set to false, the loop will terminate, and the game will be over. If, however, a condition is not found, the value will be set to true. Well, I say it will be set to true, it will remain true since it's already set to true, and another move will be allowed to be made. And that is the end of the project, actually. There's a little bit on the bottom. If no win condition is found, we just need to swap the counters over so that it's the other player's turn. And then once that's been done, it's gonna loop back round. It's gonna take counter as, well, say it's player 1's turn. It's gonna swap to player 2. So it's going to take counter equal to player 2. It's going to ask player 2 to enter a move, and it's going to do all the same thing, but from the perspective of player 2 rather than player 1. I hope this has been useful. This is the full run through of the console side of my project. The next bit I'm going to be moving on to is the server side of it. So I'm trying to use Java server sockets in order to allow two opponents to play with each other on different computers. And I will fill you guys in on where I'm up to on that in the next tutorial. So I hope you found this useful, and I'll see you for the next one.